Hello everyone, my name is Lal. I am actually studying in IT. Today, I will try to help you choose the best database and dbms for your need. In this video, I will quickly define what is a database and a dbms. After, we will look at all the different aspects of choosing a database system. Back in 1960, Charles Bachman designed the first dbms system. A database management system, known as dbms, is a software manipulating and managing databases. A database is a collection of related data. The dbms is an interface between the data contained in the databases and the software application. So the software application has to request for data to the dbms, so the dbms will accept or not the user, and if it accepts the user, the application can ask for some data that will be in the databases. So now that we understood what was a database, what was a dbms, and how it works in a complete environment, we can come to our main question, so how to choose the right database. To answer this question, we will ask some more questions. First will be what type of model of dbms suits the data you want to store. So we will see the different type of dbms, and also we'll see how to understand the data you want to store. Second question will be why do you need this database? So we'll see some important points that will maybe make you change your mind, especially if you're searching about having a database in a company. The last question will be who will do your integration, because the integration and the type of integration, the type of database you will choose may change depending on the person that will do the integration. Is it a novice or is it an expert? Is it working alone or with a group? So this is some important points that will come after. So to answer the first question, we have to see the four different type of model of dbms. So this is four big type of known model that are hierarchical, network, relational, and non-relational object-oriented models. I will quickly present the two first type of dbms models. So the first one, the hierarchical dbms. So in the hierarchical database, data is organized into a tree-like structure. The data is organized around a single root that has multiple child to which all the other data is linked. So in a hierarchical dbms, parents may have many children, but children only have one parent. Network model is an extension of the hierarchical model we just have seen, but for more complex relationships. So like the hierarchical database, there is a single root at the top of the architecture, but in this model, data can have more than one parent node. So this led, of course, to have a more complex and big architecture. Structured query language, known as SQL, is a common application that provides an easy interface to relational databases, that is, a set of tables that have predefined relationship between them. SQL databases are perfectly suited for storing and processing structured data with a mature, stable, and known to be secure technology. Relational databases are nowadays the more used and known model of database. They are organized in tables that are containers of data, organized with rows and columns. Each column contains rows, and each row in the column contains data that has its own data type. In the other side, each row has a unique identifier called a primary key and an additional foreigner key to communicate with other tables. This model is actually the star model because of this solid and inflexible construction. It has several advantages that makes a difference with all the other types. For example, its the relational database today that avoid the best duplication of data, and that is a real argument to justify the viability of the data stored in the database. It's also the best at creating limits on what certain user can access, and this plus of security had led the relational databasing being unnecessary for application that requires tiered access. We talked just before about this reliability of the data. This quality can be assured only by the compliance with ACID properties. So, what is ACID properties? A for atomicity. So, this is the principle that ensures that if a deposited transaction fails, the withdrawal operation won't take place. The C for consistency. So the principle that ensures that the validity of the data is checked before being written in the database, so to deal with illegal transactions. So the E for isolation, so that ensure that unfinished transactions remain insulated. And D for durability, the principle that ensures that the data is saved by the system even if the transaction fails. And these properties of ACID ensure the quality of the transaction and a secure managing of data. But even this fantastic relational database model has disadvantage, and the major one is its lack of flexibility. Indeed, NoSQL, also called non-relational database, were created exactly to answer this need of scalability and liberty of manipulating data. Data in non-relational databases can be changed on the fly without affecting existing data. And additionally, NoSQL databases can be run across several servers, so scaling them is cheaper and easier than scaling databases because it will be a horizontal scaling. We will come to this point after. But NoSQL databases often sacrifice this ACID compliance for this availability and flexibility. The first type of non-relational database is the document model. In this model, data is stored in a single object structure, generally in JSON data or XML documents, and is referred to as an object or a document. This object or document, each differently structured, are arranged in lists or collections. Unlike relational databases, document can contain any data desired without having a document structure. This is why it's the perfect solution for unstructured data, faster file writing, or easier scaling. So if you're searching for flexibility in your database, the document model could be the solution. Even if nowadays, after the huge wave of the NoSQL revolution, the document model is principally used to store a huge amount of information in the purpose of realizing data analysis. Another type of non-relational database is the key value model, where each value is associated with a specific key as an associative array. The important notion of this model is that the key should be a unique identifier. But as the value, it can be any data type allowed by the dbms. In this another non-relational model, we meet again this incredible flexibility. Key value databases can handle a huge amount of data and optimize performance thanks to the key system that lets the searching find the request by going directly to the value with no index. But for the system to work, the model has to store data as blob. And this is the biggest disadvantage of this database because it is impossible to query unique values. The database has to return the data as stored, so in blob. This is why the main reason key value should be chosen should be its fast and easy access, and this model should be dismissed if you're aiming to have complex structure or need query or searching more than a normal use. The third type of non-relational database is the wide column model. This model is quite special. It's a sort of mix between key value databases and relational databases. It's a column-oriented but non-relational database. This model uses key space instead of tables. So it's a really similar structure, but is more flexible because it can contain column families. Each key space contains multiple rows, and each rows contain multiple different number and type of column. Unlike the two first model, this model was made to deal better with both structure and semi-structured data. Of course, every model has its pros and cons, and dual column can be really fast and easy for writing and reading a huge amount of data, but also very slow, for example, in transaction applications. In fact, this model of database is really used in a scientific purpose because the queries on the column-based database can perform really fast results, and the data science generally contains a huge amount of semi-structured variant data. We came to the second part of the video in which we will answer the second question: why do you need this database? There's a ton of different solutions, some are free and some aren't. And the question of the price will maybe matter in the final choice. Of course, there are open source databases that you can find and easily use, but generally companies prefer databases with commercial license. And this is of course for the security of having someone to call if there is a problem occurring. The second point that should matter is the security. All information that implies users should be well protected. So the fact that you should know is that relational databases are more secure than non-relational databases. So you absolutely need to secure your database, NoSQL database, even more than necessary because this is a known fact about NoSQL. The third part of the answer is the scalability. Because as your product will grow, the database will grow as well. To maintain performance while processing this growing amount of work, you have to think about scalability solutions. To accommodate that growth, you can think about vertical scaling or horizontal scaling. Vertical scaling, it's simply buying a single and expensive and bigger server, and this will be a solution that will be optimized with relational databases. And you have the opposite, so the horizontal scaling, that is to buy multiple equivalent server that will be optimized for non-relational databases and especially key value modeled databases. The last question will be, who will do your integration? This question is really concluding the topic. First of all, making sure that your dbms can be integrated with your other tool and services should be your first move. Upon that, you should know that running a database is easy, but running a database in production could be really hard. If you're having difficulties in running your database, you should maybe think about a hosted database as part of a cloud system instead of a self-hosted database. If you choose that option, you will have two possibilities. Managed databases, that is a cloud service that runs dbms instances. So you have examples like AWS RDS, for example, that runs MySQL, MariaDB, or Postgres, or a new solution that is serverless. So it's a cloud provider that lets you simply connect to an endpoint and store your data. So you have some examples that you can go check for, like AWS DynamoDB, Azure Cosmos DB, or Google Firebase, for example. Thank you for listening to me. I hope this video had helped you choose better your database and your DBMS. You can check for all the sources in the description below. Thank you.